So today I'm going to review this FNIRSI LCR-ST1 Tweezer. Now this has got the same sort of thing which I had the Zotac one, where the branding is upside down relative to the display. Which way up do you want to have it? Pick one. This is a bit of annoyance. This bugs me a little bit. Put this the same way up as this, because otherwise it just looks wrong. Anyway, minor thing. Packaging. So I'm going to compare this with some other tweezers I've got here as well. So it's a nice bag it's in. Nice and colourful. All looks nice. Instructions. We've got the tweezer. We've got a metal plate because it's got a magnetic back on it, which means you can actually put it right around, hang it on something, so you can stick this self-adhesive backing to something, and you can then attach this to it and use it as storage. You can hang it on a shelf or something. That's got a nice touch. We've got a USB-C, USB-A charging cable, and we've got some more tips here as well, which are angle tips. See those in there. So this is sent to me at no cost by FNIRSI as well, so this is for the purpose of review. So I haven't paid for this item, it's been completely free to me for full disclosure. It's got specifications here, so it says the frequencies and the accuracies. Yeah. So that's 5% to 2%, 0.5% at best for capacitance. Gives you the accuracies at different frequencies for capacitance. Same here for inductances. 5% worst case, best case 0.5 depending on frequency and range. For resistance too, I'm just going to try and give you a quick overview of it. 1.14 inch display with a 250 mAh battery, and it does 100 Hz, 1 kHz and 10 kHz. So they call it an LCR bridge. Indications here about what the actual layout is. Dial button on the side, and test probes which have got the little thumb screw on them. There we go, some more information about buttons, how to use them, what functions they have, and there's parameters about specs though. Oh look, there's the specs in English. Nice. I thought the other one was just it, but it's okay. That's good. Operating instructions. Read those in your own time. So also it does resistance, capacitance, ESR, as part of the capacitance Q, I think, dissipation, inductance, diode as well to a limited factor. Okay, so that's the manual. Right, just turn this on and have a close look. Got the power button here, you've got a menu button here, we've got a dial up here, which is also a push button, as well as a dial. Okay, so let's power it up. So you can see straight away it's got a 0.6 volts setting there and 1K for 1 kHz. Battery indication, nice clear display, series resistance, dissipation. So we're in auto mode right now. If I close the tips together, we can see we're getting 30 odd milliohms there. Let's close them again. So we're getting about 34 milliohms there, and you can see those other factors there. There's mode, so resistance there, playing resistance mode. Capacitance mode, gives you the same readings down the bottom here. Inductance, same readings again. Diode, it's got a beeper. Shows resistance as well. That's auto mode. So we've also got, if I push that, that's changing between the voltage and the frequency. So we can change that between 0.3 and 0.6 volts. Now this is okay, but it's a bit limiting. I would really like to see like a 1 volt or 2 volt, ideally 3 volt option. 0.6 is a bit limiting. If you've got a 0.3, you probably don't need a 0.6. You probably want more like a 1 volt. Because if you're trying to do 0.3 for in-circuit testing, and you want something like 1 volt or so, then you can do silicon junctions for diodes and things like that, and transistors, and do those tests with that. In diode mode, you could then use that, but 0.6 is a bit too low for that. So 1 volt would be better. I had the same issue with the Zotac tweezer. That's exactly the same, had 0.3 and 0.6 volts as well. So it had the same little limitation there. So it's something to consider. In most cases it probably doesn't matter, but it's only really when you're doing diodes and diode junctions like you get in a transistor. Anyway, push it again, it goes to frequency, and we can change the frequencies between those. It rotates around, and push it again to get back out. Right, so if we hold that mode button down, we go into the menu, so you've got languages. I already turned this on before, that's why I had English already set. Previously, when you turn this on from new, it gives you those two options and you choose them. So we've got volume, it's currently set on 3, so you want to make that more, make it louder. Nice loud beeper. Backlight is on maximum, let's turn this down a bit. Preserve the battery. It does scroll. It's very granular. Yeah, even 50% is actually pretty good. I might go about there. so I can still see it on camera. Auto off is set to 15 minutes. It was set to off from factory. I've set to 15 minutes just in case I forget to turn it off. Restore, so do factory restore. Don't do that. And about, this is version 1.3 of the firmware. I'm not sure if there's a newer version. I probably should go and have a look. There may be a newer version of the firmware, who knows, but they've only just sent this to me, so it depends on how frequently they update the firmware anyway. Power button, hold it down, that turns it back off. And so you tap this one, that does the hold function, which I think I showed before. Alright, so that's all the features there. Let's actually do some testing and see how accurate it is. Before I move on to do testing, let's go to look at one thing. These probes here, you've got these little thumb screws to lock them on, which makes them easier to change. In a way, it's a nice feature. But what we find is that they've actually got a little bit of play and they actually move. I don't know if you can see that or not. See that? It's tipping. So if it's moved a bit to one side, we try and squeeze them together to get out of alignment. They're not locking together very well. It would be nice to see that actually be better locked down. I mean, that's pretty tight, right? I've got that tight, but it still will shift if I push it. I suppose if you're careful with them, you don't put too much force on them, they'll be alright, but they're both, like this one here is a bit looser. See that? Because it's gone loose slightly. So, this is something to consider, that you have to make sure these stay tight as well, especially for accuracy. You know, if you don't have them very tight, your readings here will change as well, because of the 4-wire measurements. Okay, so all I'm going to do is going to compare this to the Shannon tweezer. This is the ST42. This thing costs a lot more than this, and it's a good comparison because this is really accurate. I really like this thing. It's a good one to compare these two. And it also comes with a little calibration board which we can use to do testing between the two units and compare them. So what I'll do is I'll quickly test it with the Shannon. I'll show you the readings on here for the Shannon. I'll do each one. So I'll do one with the Shannon, then I'll do one with this, and we'll just go through each one and see what we get. I'm going to make sure the settings are the same. This has got 0.5 volts. So this one here has 0.1, 0.5 and 1 volt. So they're not exactly the same as what this has. They're offset a little bit. So I think for the most comparable I'm going to go to 0.5. That's probably going to be the most similar. 0.5, 0.6, I mean it's marginal, isn't it? Okay, so let's just try this. 34 milliohms. This can probably be calibrated. I don't know how. It probably does need doing. So let's do 10 ohms. 1.946, that's right. And on this one, 1.997, slightly higher. Don't forget this does have that 34 milliohm difference there. So, oops, another way so you can see it. It's 100 ohms, 99.95, and 100 ohms on this one, 99.95, same, and 1k, there you go, 9998. I know it's a bit boring, sorry, but we have to go through this process. And that's reading at 3 milliohms higher. Now this is taking a little bit longer to read than the Shannon tweezer, but then like I said, this is a much more expensive tweezer than this. So it's not surprising there's a bit of a difference there. 10k, yeah, 10.01, that looks a little bit faster actually. Maybe it does better at high resistances. There you go. 100k, bang on 100k. 99.91, bit of a drift there, 994 maybe. 1 meg, bang on 1 meg there. And 1 meg exactly there. Okay, so that's resistances. Let's do capacitances. This is 1 picofarad. Can't see it, it's too small. At least not in auto mode. I'm going to stay in auto mode for the process. 10 picofarad. No, it's probably because I'm actually at low frequency. Let's change the frequency actually for doing these capacitors. Let's do 1 kilohertz again. We'll do that again. So 1 kilohertz. Can't see it. 10 picofarad. Here we go. 10.67. Let's change this frequency to back to be 1 kilohertz as well. Try the 1 picofarad. Can't see it. 10. Can't see it. 100. Here we go. You can see 100 there, 101. It's probably because of the frequency. If I go to 10 kHz, it might show up, and it's showing 99.15. 1 nanofarad, 195. 1008. So 10 nanofarad, 10.4, 9.99. Yeah, 100 nanofarad, 98, and this is the one more already. 1 microfarad, 106, 99, 1014, reading slightly higher. Not too bad. So we've got a millifarad here as well. 1 millifarad. Let's try it on here. 1.18, it's 1 kilohertz, don't forget. It's probably where I'd want to do 100 hertz really. And yeah, 885, big difference there. But it's 1 millifarad and this will be frequency related because of that. Right, let's do 10 microhenry adapter. 10.02 or so. So it's basically 10. This one here. 8.3. We've got an LED here. This cannot light it. It doesn't recognise the LED because of the voltage. I'll do a standard diode. But you can see that it's giving us a resistance. So let's change modes. This to be diode mode. We'll try that again. We'll do the LED first. Doesn't recognise an LED. Do the other diode. There we go, 0.68 volts. So you can actually see that's a diode. But it doesn't tell you the orientation, I don't think. Let's just check the diode symbol. Yeah, so it doesn't actually tell you which way around the diode is. It'll tell you to drop each way, doesn't matter which way around you put it. So you can't actually test it individually, which direction. Obviously, because this is testing AC. And I'll show you this one as well. This also cannot show the LED. So I'm not worried by that. Let's just change modes to be diode. So diode on there doesn't show it on that LED, you can't do that. And the other diode, it can actually show it. It actually tells you which round the diode is. And it also tells you the drop as well. So that's that functionality. So the limitations are very similar between these. I think the Zotac version is very, very similar as far as the limitations go as well. But say this one does very well. My favourite one at the moment. So that's that. What else can I show you? I mean, I've shown you some basic tests. Just look at some bad capacitors. So I've got a couple of capacitors here. Just stick it on here before it goes to sleep. Oh, so it actually has an LED mode. I forgot about that. Hold on. This one will do LED. I was wrong. It's because it's got an LED mode, but it says 2.58. Forgot about that. Auto mode again. Capacitance are at 1 kilohertz right now. See what we do. 409 microfarad. And series resistance is 232 milliohms. Check it with this one. Frequency is at 1 kilohertz as well, so it's comparable. 47 microfarad, 198. It's measuring slightly lower ESR, but it is doing it. Let's check this other capacitor here. This is a 100 microfarad, 25 volt. 129, measuring 508 milliohms. And on this one, 123 at 518 milliohms. Again, very comparable. So it's all very ballpark. So it seems like its basic functionality is at least on par with what you would expect any other kind of LCR tweezer sort of thing to do with. And this seems to be at least matching it in most things, from what I can tell. So we've got these little other probes on here which we could potentially put in there, which, you know, you've got a little screw and a mounting post that goes onto. That might be a good idea actually. Curved ones sometimes very useful. Means you can test more easily instead of trying to go like this. You can test more like that. So it's got some inductors out. Let's have a look. See how it goes on some inductors. We'll try the Shannon tweezer first. This one's a 470 microhenry. That's reading 444 at 1 kilohertz. It's measuring resistance of 5.54 ohms. This also at 1 kilohertz, 457. with a 5.26 ohms resistance down the bottom there. So that's alright, it's close enough. This one's a bit more challenging for it. Let's try with 1 microhenry. Seeing it as a resistor. It's change modes. Inductance to manual mode. Still 1 kilohertz. Getting 0.4 microhenry. See if this one can do an auto. No. It's doing also 1 kilohertz, about 900 or so. Struggling a bit 1 kilohertz. It probably needs a high frequency. Let's try 3.3. Yeah, 3.39. It's getting there. This one here, 2.5. Bit of a difference there. That one's more accurate at these lower levels. I don't know if there's a way of calibrating this thing. Really don't know if there's a way of calibrating it. It may need it if it is adjustable. So that's a bit out of the lower end there. Let me see if there's a way of calibrating it. So apparently to zero it, you push this to zero it. So that zeros. Let's try this again. Try and get the same one. I think it was that one. Shouldn't really matter. 1.9. 3.3. So I did a zero on it, but it was no better. Let's try changing frequency. 10 kilohertz. Maybe it'll do better there. 2.4. We'll do zeroing again. Try it again. 2.4. Yeah, so I can't actually do that. Accuracy at these lower inductances, not so good. Let's try this one again now I've done the zeroing. This is 467 now, 100 hertz. 1K, 458. Yeah, okay. Yeah, it's a bit inconclusive. But it was nice that we actually found out about the zeroing though. That could be useful. Then I try to do zeroing like that with it open on inductance. Just try that. It says short, but maybe it's opposite for inductors. 1.8. No. Okay, so low level inductances it struggles with. High levels are seemingly okay. Alright, let's try this 0.1 ohm resistor. I've got it set to DC resistance on this one. It's measuring 101.8 milliohms. Let's see what this one says. This isn't DC, this is just still AC. 60. Okay, let's do a zeroing on this one. This one might zero. What's going on with this thing? This is being weird. If I stick that across there, it's a negative milliohms. If I zero that and take that off. Okay, so this isn't actually a 0 milliohms. That's weird. Because that's actually going negative values. So that's actually a negative 35. 37. That's negative 37. And that's 100 milliohms. Yeah, so that's actually interesting. I'm not quite sure. I might have to look at that some more. Well, what instructions saying here don't seem to make sense to what this is actually doing. I mean, if I try and do that with nothing across it, right, it does nothing. And I'm out by, you know, a lot. And if I short them together, then it says I've got 100 milliohms there. But each time I push it, it changes. Alright, so that seems to have stabilised there, but now I'm getting a completely wrong reading. But if I do it with that across it as 100 milliohms, it's no good. You can see 64 was short now. 100 with a short. I stick that across it, that's now 4. So this zeroing doesn't actually seem to make sense. I'm confused by it. I really don't understand. That just doesn't seem to work the way you'd expect it to, or as per the manual says. Yeah, I don't know. I need to investigate this some more, but right now it doesn't make sense to me. So when it comes to zeroing this, I've tried all different things and I just can't actually seem to get the thing to behave the way it should do. I mean, shorted, that's doing a negative 33 milliohms. If I release the pressure, see it goes upwards, which means the resistance is getting worse. So as I increase the pressure, it goes down. So that's negative value, and I cannot get it to actually zero. And if I do that to 0, it goes up. It's like it toggles the other side, and now it's gone to 100 milliohms. It's like, well, and it's a 100 milliohm resistor. Stick that across there. Now you're getting nothing. It's negative 100 milliohms. Do it again. 55. Do it again. Got 6 again. 55. It's like, so I tried doing some 200 milliohm resistors, and no, that didn't help. Thinking maybe if I do 200 milliohm with zeroing, it might actually bring it down. It's like, so although it says you can zero it, you can't. There's a bit of an issue there. So there you go, short again, 34. So when you power it off and turn it back on again, it does at least take that error away again, but it's still out by 34 milliohms in negative direction, and I can't seem to get rid of that. So if you're worried about doing small values like this, then this could be a bit of a problem for you, because the zeroing doesn't work, at least not on resistance. So right now I'm just changing the tips over to this other type, just in case that has an effect. Maybe it does, maybe it doesn't. So they're pretty easy to fit. You just take the little thumb screw out, remove the tip, and slot the other one in. So that's nice and straightforward. Tips in, they align. Does that change anything? Still 33. Let's try a different way. I've put two 100 ohm resistors, sorry, 2.1 ohm resistors together, and let's try and get onto these and then see if I can, I don't know, how I'm going to do this, I'm quite sure, but I'll figure this out. And then zero this one, you can't see what I'm doing. So this value won't actually let me zero it. It's too far out of whack. So I can't zero that. Stick on that one. It will zero that one, which then goes negative 100. I'll stick it on here, which you now can't see. That says 100. Yeah, the zeroing doesn't work properly. Well, I think time for a summary on this thing. It seems to work basically okay. Obviously the very low inductance it doesn't like, it's a bit out there, and the very low resistance is also a bit out there. The zeroing, as you saw, I cannot get to work. It just won't do it. So it tries to go negative 100, and if I put 100 across it, I can't actually get it to do it. So yeah, I don't know what's going on there. It's a bit weird. I think otherwise it's okay. It's got a nice big battery in it. That's something, I suppose. If you want a battery, it's going to last a while. And if you're trying to do these things for like surface mount work, then that's great, especially with these tips on these curved ones. You can get on the components quite well with that, and I think that's actually can be very effective. Like, you know, there's a surface mount board here. You know, there's not much on it, but some LEDs there. You can get onto those easy enough. Yeah, dead easy. So no problem at all. You know, regulator, whatever. So I mean, it can get on there easy enough, but it's just not quite perfect. You know, just that little bit of error there with the zeroing. 1.3. Right, I'm going to go and see if I can find a newer firmware in case that changes that. So there is a newer firmware for this, version 1.5. Only problem is I can't get the bloody thing to load it. I've gone into the bootloader menu, following the instructions in here, followed the instructions exactly. I drag the firmware file into the disk that pops up on the computer when I have this plugged into it in firmware update mode. Nothing happens, look. It just says 0% all the time, and never actually goes any further than that. So I tried it going to bootloader mode, like this, and that didn't do anything. So you push and hold that down, press that, go to the bootloader mode, right? So I've done it with that plugged in. I've done it turning it into the menu, then plugging it in. Both times I get the same disk pop up. I'll put the firmware file onto that disk, and nothing happens. It just sits there like that. Yeah, I can't actually update the firmware. I don't know why not. Maybe it's because I'm on a Mac instead of a PC. Maybe that's the problem. But still, a disk is a disk is a disk if it shows up. Well, thanks FNIRSI for sending that to me at no cost. That was brilliant. I mean, it's got uses. There's a few little quirks. I mean, the firmware thing I can probably sort out by using a PC. I use a Mac though, so not so easy, but it's not impossible. I could definitely try it on a PC. The firmware revision information didn't say anything about correcting, zeroing or anything like that, so there's no mention of that in the changelog. So even if I do update the firmware, it probably doesn't fix that anyway. Firmware downloads on the FNIRSI's website, so it's easy to get and stuff. You know, just go to there, go to the downloads section and download what you need. Anyway, thanks FNIRSI for sending that to me. Got other videos down here you can watch, reviews and what have you. Subscribe over here if you're not already subscribed. And if you want to support the channel, help me to buy things, do videos about fixing them, there's a Patreon link over there. A couple of dollars a month, that's all it takes. Catch you later.